Hello students, before starting the class today, I would like to say to you that yes, the whole notes of this whatever I am teaching right now is given you in the link along with the video. Okay, just click it and see the notes, and along with it you can study also. Okay, so now let us come with the topic today, that is 3D close packing from 2D HCP layer. What is this HCP, hexagonal close packing? Okay, so how this 3D close packing occurs, okay, from the 2D hexagonal close packing layer. Okay, it is by two ways. Okay, first is the placing of the second layer over the first layer. Okay, and the second is placing of the third layer over the second layer. Okay, so in the first 1D we had studied, 2D we had got what, square and the hexagon, isn't it? Here you are seeing over here, this is what the 2D structure. Okay, this is the hexagonal close packing of what, 2D structure. Okay, and here we had got what, a hexagon. Here what will happen, we will be placing one more over this layer. It means this layer is present up, along with it second layer is placed. Then you will get some structure like this. Okay, these dotted lines are showing about what, the spheres, okay, which is placed over the first layer. Okay, so what happens naturally, here a word comes voids. Again, I have said to you earlier also, mentioned earlier also, voids are just empty spaces. Okay, so voids, when it will be caused, okay, these are spheres. Naturally when they are arranged, what happens, you arrange it. Okay, now in this manner if it arranged, you get a void. This is a trigonal void. Okay, but we nothing to do with this trigonal over here, because here we will be getting what, when we will be placing over it, we will be getting a tetrahedral void. Okay, here you can see 4 spheres are involved. Okay, here 3, and along with that 1 is placed over here. Okay, and that creating a what, a tetrahedral void. Okay, now next, octahedral voids are also caused in this. Okay, if we are saying about any number of sphere in close packing, we are taking n. So number of octahedral void is n, number of tetrahedral void is 2n. Okay, just listen to that. Here we have seen what, the tetrahedral void. Okay, now what happens when it is placed, what, the octahedral voids also exist in this. Okay, and the structure of that octahedral void is this, in this manner. But yes, if we want to explain it in, okay, so here what happens, in that you have seen in tetrahedral 3 spheres above it is placed 1 sphere. In this what happens, you will see that it occurs in this form, and as the result creating a what, octahedral void. Okay, and as the result here 2 types of voids we can see, that is the tetrahedral void and the octahedral void. If the number of octahedral void is n, then naturally tetrahedral voids will be 2n. Now we are going to study placing of third layer over the second layer. Okay, we have studied about placing of second layer over the first layer. Okay, so now proceeding with placing of third layer over the second layer. Actually what happens in this third layer, placing of third layer over the second layer, here we are covering the voids which we have seen which had been created in placing of second layer over the first layer. And which voids were created? That was the tetrahedral and the octahedral voids. So here we will be basically, what we will be doing in this placing of third layer over the second layer, we will be covering the tetrahedral voids and we will be covering the octahedral voids. Okay, so now, so you remember what are voids? They are what, empty spaces. Okay, now do you remember this, the structure of the tetrahedral void which I have said? Okay, this was this type, 3 circles, over that 1 circle, isn't it, creating a tetrahedral void. So here what happens, we will be covering this tetrahedral void. How we will be covering? We will be again placing one more tetrahedral void structure over it, and this type of structure we will be getting. Okay, and as the result now the void is covered. Okay, and so here the structure which we will be getting will be HCP, even though it is what, face centered. Okay, but the structure we will be getting will be hexagonal close packing. We can see in case of magnesium and zinc, the structure which comes out will be like this. Okay, here you can see the difference. What is here? Here a tetrahedral void B is represented here. Placing one more tetrahedral void over it, we get the structure, कौन सा structure मिल जाता है? We get the structure, this middle structure, that is A. Again we are taking the tetrahedral void. Again we will be placing one more, and we will be getting what? It will be covered, the void created. Okay, and the structure which we will be getting will be what? HCP. Even though I said to you it is face centered, but the structure we will be getting will be hexagonal close packing. Okay, example we can see in magnesium and zinc. Okay, now covering of octahedral voids. Okay, octahedral voids, I said to you, if octahedral void is 1, tetrahedral void will be 2. If octahedral void is what? N, tetrahedral void will be 2n. Okay, so here you can see what this covering of the octahedral void. Here there is a difference from the tetrahedral void. Okay, and the difference is the one more structure which we are seeing over here, it is C. Okay, because we have to make one more, okay, to cover the what? Octahedral voids. And naturally when this is placed over that, we get a structure in which it is totally covered. A. Okay, here this over this will be getting what? The covering of the octahedral void, and the structure which we will be getting will be a cube, and that will be what? FCC, that is face centered close packing. An example we see in copper and silver. Okay, so when we have studied this, okay, all the placing of the second layer over the first layer, the third layer over the second layer, covering of the tetrahedral voids, the octahedral voids. Okay, the efficiency now we can see from this structure, so much of packing is going on to avoid the voids. Okay, so naturally we will be seeing in this the packing efficiency will be more, it will be more close. So now here we see what? That they have the packing efficiency of 74%, which I will be explaining you in the next video. We will be deriving it, how we are getting 74% of packing in this. Okay, and the coordination number which comes out is how much? 12. Okay, so this is all for today. Good day, take care.